I'm going to talk a little bit about animal mitigation, and really what I want to spend the time for some reason we're not. Is my screen working correctly?
Yes, it is. Everything's
Okay,
fine.
great. So what we're looking at is, and what I want to talk a little bit about today is how wildlife protection should not be an afterthought. If we look at TransGard's history, a lot of the interactions that we have with our customers are after an animal has come into a substation and created havoc. And where we're at is looking at being proactive versus reactive. Here in this substation, it was active for about 25 years with no problems whatsoever. And then one day, a raccoon made its way into the substation and created a fire. The fire was broadcast all over the news. It was a big local event out in the Midwest. And unfortunately, this transformer actually supplied a glass factory and a hospital. Both had some issues downwind of the problem and created a big issue for the for the electrical provider at the time. Now, going forward, if they had a proactive approach, they probably could have avoided this situation. The issue that we have today is that lower reliability ratings are tied to power outages and interruptions. And really, with major events that happen across the country today, you can expect that an average consumer is going to anticipate 8 hours of power interruptions annually. And that in turn goes down to lower reliability ratings for the provider, which in turn affects a lot of things on the national level, but also I truth believe ratings and things along those lines. Up to 20% of all outages in the US are attributable to birds and animals, with about 18 to $30 billion of lost economy every year. Being reactive to the approach of animals in a substation lends you to tremendous risk to high repair and replacement costs. Squirrels is such of a problem that there's an acronym that is used by a group out in the western part of the country called Power Outages Caused by Squirrels, or POCBS. And it's actually tracked by the American Power Association, and you can see what they look at is incidents in substations in their environment that or in their marketplace that have created outages. In addition to that, Cyber Squirrel 1 has been around for years. It started out as kind of a gimmick, but now is recognized around the world as a true gauge to look at possibility of animal incursions in a substation or actually tracking of animals in a substation. And it's used, once again, it's used around the world. One of the things I note here is that back in 2015, a former deputy director of the NSA recognized that animals were more of a threat to the electrical grid than possibly any other issue that could happen. So today, when they look at it as a threat, the government actually looks at animals as a major threat to the resiliency of the grid. So the effects of birds in substations, there's outages and hazards. Outages are common across when you have a larger bird that can go phase to phase or phase to ground. But the hazards really are underlooked a lot of times, and they really revolve around the health and safety of the workers in the environment. Bird waste, and we'll talk a little later about it, is a very hazardous and causes up to 60 known diseases, and can relate to liabilities and issues along the lines of lost productivity, and ultimately maybe even a lawsuit of a hostile working environment. And also lately, we've been seeing liability issues on the government side of things in protected species. Lots of things have come up. We've seen fines in the millions of dollars for birds that have been affected or killed by electrical supply across the country. And really the problem with birds is there's very limited tools to eradicate them from a substation. So what is TransGard known for and how we can help in this? TransGard has been known as the animal fence protector for the substation environment for 20+ years. The animal fence is designed to keep climbing, crawling land animals out of the substation. It was designed by substation engineers and along with other people in the electrical provider industry, and really designed to protect the substation on the critical components that could be resulting in damage from a contact of an animal in a face-to-face or face-to-ground situation, typically on the low side of the environment. It's been such an effective use that we've had almost 4,000 substations across North America. And the advantages of the fence are really an easy installation. We don't have to take a shutdown to install this fence to protect the low side or the high side or an entire substation. It's a freestanding protection with modular design. It can grow with the substation, be easily adapted to a new design or a new area of protection, and can be taken down quite easily to get larger equipment in when necessary. We have an engineered entryway that allows access for personnel into the substation through without having to turn off the fence, and keeps them safe. We have a wide range of protection in species. Think about it: if it can crawl, climb, walk, jump, we can protect it with this. It's made from durable materials, mostly cellular PVC and stainless steel aluminum that conform to the UL 94-V-O flammability standard for plastics in the substation environment. We also have an engineered base to keep the fence stabilized in the environment without permanently anchoring it. Laser bird defense is a newest product for us, and what it's designed to do is create a hostile environment inside of a substation where birds would roost or nest, keeping them out. Advantages there, really easy to deploy. The laser is autonomous itself. It has a very humane and positive perception. It's a low impact to the environment. There's not sound or chemicals used, and it prevents habituation of the birds coming back into the substation. Really talk a little bit more in detail about it later, but it steers birds away from the substation. So our animal fence protects against squirrels, raccoons, ringtail cats, opossums, snakes, mice, rats, and other ground animals. What we have is a modular design, as I just talked about before. The advantages: there's no outage or digging into the substation to anchor the fence. It only goes in about 6 inches below the gravel and then is covered up to the bottom rail by gravel. The power to supply the fence is done usually close to the control building and requires a standard 110 outlet or 110 circuit to control it. The installation typically takes 1 day, can be installed by the crews from the customer, or we can provide installation assistance from the standpoint of crews, complete crews, or just observation or supervision. Just 3 panel sizes for flexibility in design. Our most common size is our 10-foot panel. Then we offer a 6-foot and a 3-foot panel as well. We have a snake panel option, which in the environment, typically more in the southern region of the United States, where snakes are prevalent, we have a stainless steel perforated option on the lower half of our fence, which prevents a snake from 1/4 of an inch or larger from getting through. And we've determined that, along with animal experts, that anything less than 1/4 of an inch is not going to pose a threat to the substation. Personal safety, we have the entryway as well as an exit panel. The exit panel would be used in an emergent situation where it has a panic bar, much like doors on a commercial building, that allow exit quickly. And also we have a grounding module, which takes any residual energy that's left in the fence and moves it to the substation ground quickly, so that we do not have any residual charge on the fence once turned off. We have a control monitor or control center attached to our entryways. This has a beacon, typically can be programmed for red being on, green being off, but it can be also turned in the opposite direction, green on, red off, which has a lockout tag out on it and a high visibility voltmeter to see that the voltage running through the fence. Real quickly to describe how the fence works, once the fence is installed, we energize the fence and we pulsate 12,000 volts, 1.5 seconds through the fence. It's enough voltage to actually deter an animal without hurting it. So the animal would come in contact with the fence. We have alternating positive and negative charges up the fence. They would come into contact with that, feel it, move away, and not try again. The entryway is designed to prevent any climbing animal from getting over it. It's a smooth point of contact, so we haven't had any issues with animals getting over the gate area as well. One last thing that comes up a lot in question is high wind applications. We can anchor our bases. You can see in this point right here with an anchoring bolt through the the stand that we use, and that would again be in a high wind application. And finally, we can hook this up to SCADA. So it's a binary situation where it shows the fence is off or on for remote monitoring. We have the ability to do custom installation. So as I said earlier, the fence is designed to be very modular and very easy to put in. You can see a lot of different applications here where we've gone through cable trays, oil berms, and for some reason my screen seems to be not reacting anymore.
Really? Okay.
Yeah,
Well,
I don't know if it's on my end. Yeah, I cannot click through the presentation. Oh, there we go. Let me
all
see if I
right.
go back to one place. So walkways and walls as well. In certain instances, we can terminate our fence up against the control buildings or anything like that and still have active protection across it. One of the things I note in the picture up in the right-hand section is we tend to design the fence to be in a zigzag formation around the protected equipment, and that's to help with wind loading. when we do that, it actually stabilizes the fence and helps it become a more resistant to wind. Now, moving on to the flying birds and avian side of things. We've come up with our latest product is laser bird defense. And really what I'd like to describe to you is how this works. It's designed to modify the bird's behavior. It doesn't zap the birds. It doesn't do anything other than make a hostile environment for them. And if you could picture yourself inside of an office, your office, and you're sitting there, you're doing work, you're getting ready for a presentation or doing a quote or some kind of any kind of work, and you're at your desk and these green lights are bouncing all over the room, and you try everything. You try turning off the light switches, you try the curtains, you try blinds, you move your desk, you move your chair, and nothing happens. Eventually you would get up and leave that office to go to a different space. And that's exactly what laser bird defense does. It exploits the bird's number one use of its senses, which is sight. They have a very good sight use, and they can see a lot more than humans can see. So if you look at the picture now, human vision sees a blackish gray bird, and a bird would actually see all of those colors. So we take advantage of that with the laser bird defense. Again, what we do is this video shows a misty night where the lasers are visible, and you can see the hostile environment that is created by the lasers. Now, normally you would not see the beam, only the birds see the beam. The birds see that beam in bright daylight, dark night. We see a dot that hits the equipment. Show that a little bit later. Designed to steer the birds away from the substation. It is, again, the creating the hostile or chaotic environment that they would not be welcome in. What we found is we've got a very good success rate with habituation or non-habituation, where birds do not return to the substation. A lot of the other products that we've tried in the past to help our customers eradicate birds work for short term, but birds get accustomed to it or used to it and really don't care anymore. But with lasers, it seems that they're not very interested in coming back to a substation long term. The key components are the laser itself. The laser is a class 3B laser, which is safe for skin, but unsafe for eyes. So we've done some certain things to make it usable. A class 4 laser would be the laser that is used for cutting in industrial and medical procedures, but the class 3B is what we use in this laser. How we make it a little bit more effective in substation use, as well as protecting it against human eyes, is we actually use a diffusing lane, and we take that narrow beam, what everybody thinks of a fine point of a laser, and we spread it out to about 50 millimeters, which is a little larger than you'd see an oval shape about 2 inches, 2 to 3 inches on the equipment itself. This allows us to have a much wider beam that the birds see, as well as keeping it safe for human consumption. Why green? Green is the color spectrum that birds respond to the best, as well as a color that we can see very clearly. When we program this, we need to see the beam. So we could use some of the other spectrum colors that birds look at, but we would have a difficult time programming that. Motor platform is key. So the motor platform allows the laser to move around the substation. You can see in this video, we have a specially designed bracket system that keeps the laser below horizon level. So it's a few degrees below the horizon, so it can't point up into the sky, which makes it FAA regular or FAA compliant. The system itself is programmable through software, which we use pretty much a cell phone or a tablet through Bluetooth connection to program the laser to target specific pieces of equipment where birds would be roosting, nesting, or just accumulating. And finally, there's a status indicator, which helps tell the status of the laser and the operational sequencing from the ground. So it's very simple to see that the laser's in full operation. Steps to success on this is real simple. We look to pinpoint the specific species that are in a substation. It's very important to note what kind of birds are there. Some birds react differently to this, and we would need to know that to make sure that there's a good solution. Target the equipment. You can see in this picture, there's a ton of starlings up on there. Pretty easy to see where they are, but sometimes it's a little bit more difficult. So we have to do a thorough inspection to see that. Pick the tools. Which one's correct? There's a lot of bird mitigation out there. What's the right solution for your environment? Build the infrastructure. These lasers require being above the equipment. So a lot of times we look to use existing structures in and around the substation, but sometimes there's a requirement to put poles into the substations to mount the lasers above high. Prep. One of the things we can't emphasize enough is it's very important to start from a clean environment. In fact, when we put a laser in a new substation that hasn't been inhabited with birds, we have success right off the bat. So it may take a little bit of time for a bird or an animal in general that has used to going into the substation to be eradicated. So we look to prep, which is a thorough cleaning, and that means nest removal, guano removal, and cleaning of the equipment. And finally, oh, we're locked again. Oh, there we go. Finally, we do the mitigation, which is installing the equipment and programming it. Once the equipment's up and running, it's pretty autonomous. It doesn't really need to be activated or looked at too closely, other than turning it off when you go into the substation and turning it back on when you leave the substation. We truly advise that it should be turned off when people are working in the sub itself. Where to start? Site information. It's really simple. Whether it's greenfield or existing site, if we have the data on the substation, including elevations and things like that, we can easily put together a design which includes placement of lasers, laser coverage, and things like that. We then would put together a detailed proposal explaining exactly what we would be doing, as well as what would be required from the from the utility itself on what was required on their end. And finally, site prep or the installation. We do site prep, as I said, targeting those nests, put the infrastructure in, which includes power to the pole. Again, it's just an AC connection, the standard outlet. We mount the lasers, program it, which is probably the most critical part of this. We actually look to target specific equipment. So you can see the green dot bouncing around there. That's what we're looking to do with that laser. So we program the laser to hit certain points of the equipment. And I like this little short video that we're showing here is because we keep the laser confined to the boundaries of the substation. The big question comes out is, does the public see it? Or in case of here, we have a parking lot right next to it. No, the laser is actually bouncing inside of the substation off of the equipment. And you can see it's got very specific targeted points. The software is designed to halt the laser should it get deviant from its programming, where the next waypoint is not followed, the laser would shut itself down because we do not want it to point outside of a substation or get just randomly go on its own. These programming, each laser gets a whole bunch of different time slots that we actually program these points in, and the software itself generates a random pattern to how it provide or moves the laser through the day. So never does the laser repeat itself, and it works in conjunction with multiple lasers inside of a site. Typically, we look at a minimum of 2 lasers up to 7 or 8 in the larger substations, and they're all working in concert together to make sure that the birds are not moving from one side of the substation to the other. And from my perspective, I've kind of covered all of it. I know I went quickly. Can I answer any questions for you?
Yes. Hi, Bill, I have a question. What is the, is there an estimated cost to these animal outages, these outages caused by animals?
So as the one slide says back in the early in there, there's a number that's floated out there, and it's generally used. It's 18 to 30 billion dollars of lost productivity, lost money, and that includes downtime from the consumer end, providing electricity to the consumer and equipment. You can imagine that we get involved in a lot of the situations where a squirrel or raccoon gets into a substation, blows up a switch, can blow out a breaker, but also can blow out $1 million transformer. So it's really why I predicated this to be upfront, saying that it's really important to look at being proactive in protecting a substation, because you never know. That story I told about the substation in the Midwest, where 25 years they never had a problem till that raccoon showed up that day and blew up. That in that case, it was almost $2 million transformer. They never suspected it, but if they had taken the proactive approach years ago, they probably would not have had that situation happen. So hopefully that answers your question, but it's more on an individualized basis.
Sure. How much does this kind of system cost for a substation?
So in general, the fence is, we can quote the fence in footage. The typical substation fence, you're looking about $80 to $100, depending on the options you choose for the fence panel itself. And overall, an average substation in the Northeast would be somewhere between $20,000 and $30,000 to protect. Some of the larger substations, they can get higher than that, but on a normal basis, depending on how many entryways you're looking at putting in, you look at about $80 to $100 for the fencing, and then there's a lot of things that go on top of that. But on general, about I would give a good estimate about 34,000 to in this area.
Right. Where was this laser bird defense system tested?
So the laser bird defense comes from where we discovered it was in Europe. A company was using them to protect orchards and vineyards. And really what they were doing is seasonally, they would install these lasers when berries and grapevines and fruit got ripe, to keep the birds out in that short window of time when they could be harvesting them. We looked at, our engineering team discovered it and kind of pioneered the fact that, hey, if it works there, it'll probably work in a substation. The studies that have been done to date are few and far between, but the one I note the best is there's a study from the USDA that looked at lasers as a tool to deter birds from the farming environment as well as from the airports. And their main goal was to determine whether the laser was a problem for birds. And what they came out of that is they came out with a recommendation that the laser does not harm birds and is an effective tool, and she can be used in airports and in farming environments. We currently are looking to put together our teams are looking to get some independent studies specifically on substations and things like that, but it is a newer technology, but has been around for many, many years in both agricultural and as well as being used in airports around the country.
Right, good. And the final question, what's the difference between designing this into a new substation as opposed to retrofitting a substation?
So there's challenges to both, but a new substation is fairly easy. We kind of know from existing substations where birds are roosting, nesting, and the preferred equipment that they go on, plus the equipment that we need to protect. So in a new substation, it's fairly easy for us to say, hey, poles should be placed in these locations. We know the height of the equipment from the drawings, so we can put all of that in there right away. The challenge for us becomes in existing substations, a lot of times requires some detailed site visits, and some of that photographic stuff you talked about earlier, drone flights and things like that, to make sure that we're actually putting the lasers in an existing substation that does a number of things. One, first and foremost, gets rid of the birds, but also allows efficient operation inside of the substation. We can't just put a pole in the middle because that may be a high traffic area. There are also considerations in the environment around the substation of use of existing poles or things like that. So hopefully that answers the question. I would implore anybody who's thinking about putting in a substation to look at animal mitigation right up front instead of waiting down the line and being reactive to something that happens, because you can capitalize that cost into the cost of the substation and have protection from day one.
Okay. What is a ROM cost for the laser bird defense?
So laser bird defense, it's all basically, it's hard for me to give you a number from the overall cost of the job, because I'm not sure what infrastructure is going to need to be put into the substation. But what I can tell you is, from the TransGard perspective, each laser that we put into the substation is around a $15,000 to $20,000 item, each laser. So considering the size of the substation and what we have to protect, the minimum would be 2. And again, as it may be a complicated situation, we may need 7 or 8 of them. What that includes is us coming out and doing the programming and making sure that everything is lined up. It does not include the infrastructure, mounting of the lasers and running the electric to it.